Hello everyone, welcome back to my channel. I am Sanjana from Computer Science and Engineering from Sri Venkateshwara College of Engineering, Bengaluru. In this video, we are going to discuss about vector spaces in mathematics. What is a vector space? Let us see the definition first. A vector space is a set of mathematical objects called vectors which can be added together and multiplied by scalars to give other vectors in the space. And we'll see the properties of vector space. A vector space must satisfy certain conditions including closure under addition and multiplication and the existence of the additive identity and inverse. Now let us see the examples of vector spaces. Examples of vector spaces include Euclidean space, the space of polynomials, and the space of solutions to a system of linear equations. Importance of vector space. Vector spaces are a powerful tool for solving linear equations, analyzing data, and optimizing engineering systems. Basis and dimensions of a vector space. A basis for a vector space is a set of vectors that are linearly independent and span the space. Any vector is the space that can be expressed as a linear combination of the basis vectors. Dimension. A dimension of a vector space is the number of vectors in any basis for the space. It is a fundamental property of the space and cannot be changed by linear transformations. Examples are the standard basis for Euclidean space is a set of unit vector in each coordinate direction. The dimension of Euclidean space equal to the number of coordinates other vector spaces in finite dimensions. Now let us see what is linear transformations. First we see the definition of linear transformations. A linear transformation is a function that maps one vector space to another in a way that preserves vector addition and scalar multiplications. And applications of linear transformations. Linear transformations are used in many areas of engineering, such as control systems, image processing, and data analysis. They can be represented by matrices and are key to solving systems of linear equations. Now let us know about eigenvalues and eigenvectors. An eigenvector of a linear transformation is a non-zero vector that is mapped to a scalar multiple of itself. The corresponding scalar is called an eigenvalue. Eigenvalues and eigenvectors have many applications in physics, engineering, and computer science. Applications of vector spaces in engineering. Robotics. Vector spaces are used to model the motion and control of robots, such as manipulators, arms in manufacturing, or drones in aerial surveying. Computer graphics. Vector spaces are used to encode and manipulate images, animations, and 3D models in computer graphics and virtual reality. Circuit design. Vector spaces are used to analyze and optimize electrical circuits such as those found in power systems, electronic devices, and communication networks. Structural analysis. Vector spaces are used to study the stresses and strains in materials and structures, such as bridges, buildings, and airplanes. Challenges in vector space calculations. Numerical errors. Vector space calculations can be sensitive to round-off errors, especially when dealing with large or ill-conditioned matrices. Special techniques such as pivoting and scaling can help to mitigate these errors. Computational complexity. Some calculations involving vectors and matrices, such as finding eigenvalues, can be computationally expensive. Algorithms and software libraries having been developed to handle these calculations efficiently. Now let us see the real world complexity. In many engineering applications, the underlying physical systems are complex and may involve non-linearities, feedback, and uncertainty. Vector spaces provide a useful framework for modeling and analysis, but additional techniques are often needed to address these complexities. Now let us come to the conclusion of vector spaces. Vector spaces are a powerful and versatile tool for modeling and analyzing and optimizing systems in engineering. Understanding the key concept and applications can provide insight and opportunities for innovation. However, the challenges and complexities of vector space calculations should not be underestimated. As with any mathematical tool, it is important to use vector spaces approximately and with a clear understanding of their limitations. Thank you for watching. Please like, share and subscribe.